All right, so let's continue with this. We haven't really talked about arcs in here, have we? Or did we? Did we talk about an arc?
No.
I don't think we did. All right, so we're going to talk about that today. And so let's start off with a picture of a circle. It's a good start, since this whole chapter is about circles. So the first little part of this is going to be just some vocab and some notation, okay, how to write some things. Seems like every time we learn something new in geometry, we always start with that, right? And then you get into what's equal to this, what's the relationship between these angles and segments and all this other kind of stuff. So it's kind of the same thing, except we're dealing with circles this time. All right, let's see where I want to start. All right, let's start here. So that's the center of the circle. So what if I make an angle? Let's just say like that, okay? Let me just see where I want to go with this. All right. All right, so let's say we have an angle. All right, let's say that's 60 degrees. This would be an angle, and this would be the center. Let's put some letters in here. Call this W, call this X. That's all we'll call it for right now. We're going to put some other stuff on here in a minute. It's really gotten stuffy in here just in the last few minutes. It wasn't like this earlier. So if everybody could stop breathing for a while, that'd be nice so it wouldn't get so stuffy. All right. Just kidding. All right, let's do this. Have we talked about this angle in the middle here?
The central angle.
Okay, we did talk about it, yes? All right, so we call this the central angle. So let's review that. Central angle. Now, what happens is that's the angle. Now, why is it called the central angle? Because the vertex of the angle is where? At the center of the circle, okay? So this dot right there, it's not just any old dot, it's the center of the circle. So we call this angle, we call it the what? Central angle. Everybody good with that? All right. Now, this angle cuts off part of the circle. I'm trying to remember what we did in here, what we did, because I just finished teaching circles to another class, and so sometimes it's hard for me to remember when I said what, especially when I teach these things so close together. So tell me if I've done this before. Have we talked about this little spot right here, like from there to there? Okay, it's not a segment. Okay, this is called an arc. It's called an arc. All right, so it's part of the circle, isn't it? It's just like a little piece of the circle. We're not talking about the whole entire. Did we do segment and sector? We didn't do that. Did we do sector?
Yeah.
Okay. Man, I can't remember anything about what we've done in here. It's all running together. But anyway, it's not this whole area, right? We did the area of a sector, area of a segment, yes? All right, so it's not that. It's just this little line right here, okay? That thing right there. Now, we measure an arc in degrees, all right? So just like an angle is degrees, this is 60 degrees, we measure an arc in degrees. Before I talk about this arc right here, what if I started at W and I went all the way around the circle, back to W again? How many degrees is that around a whole entire circle? 360, right. You've known that, haven't you? Right? You've known that since, I don't know when you learned that the first time, at least middle school, right? Maybe before that. Kids that do skateboards, and my son used to do scooter riding. You know what the scooters are? It's kind of like a skateboard, except got a handle on it, basically. But they would do 360s, right? When you go skiing, right? These guys that jump off ramps, they jump off the ramps, they do a 360. Even dunking with basketball, right? Dunk contest, he goes up and he spins all the way around. He does a what? A 360, all right? So that's all the way around the circle. So we measure around a circle in what? Degrees. Not talking about how far, right, he went. It's just the angle that they went. So if you start here, go all the way around back to where you started, that's 360 degrees. What if you started at W? There we go. What if you started at W and you went to here? We'll call it Y. How many degrees is that from here to here? It's 180, right? My dad he brought this up to me one time, and I never had thought about it before, but it's not always preachers, but every once in a while somebody will say, I was living my life of sin. There's a preacher up there. I was living a life of sin, but God came and took a hold of my life and turned my life around 360 degrees, right? Is that really what he wanted to say? He wanted to say? No, if you turned your life around 360 degrees, where are you going? You're going the same way you were going to begin with, right? What do they want to say? What are they trying to say? 180, right? God turned my life around, what? 180 degrees. That means you're going the what? The opposite direction. Exactly right. Now, I haven't heard too many people say that, but I have heard that. Guys? I have heard that on occasion, all right? And everybody just sits there, yeah, amen, praise the Lord, all that kind of stuff. I'm like, no, you said it wrong. You didn't turn your life around 360. Well, maybe they did. Maybe they didn't change anything in their life. Then you did turn around 360 degrees, all right? But you know what they meant, right? You're going in the opposite direction. So, can I please just tell a little story with you guys going ballistic, all right? It'd just be so nice. So anyway, I'm just trying to get you to understand what we're talking about going around a circle. 360 is the whole way, 180 is half a way, all right? And what is this? This is like 60 out of what? 360, all right? So what would that be? Like what? Not half, but what? 60 out of 360.
A third. No, less than a third.
What is it exactly? 60 out of 360.
Oh, that's 6. Well, that's 6.
1/6, yes. That would be 1/6. So this would be 1/6 of the way around the whole circle. Agreed? All right. So that's what I want you to think. Now, we have a way to represent the arc, and this is what we do. So what do you think we would call this arc, this red one right here? What do you think I would call it? WX, that's right. Okay. Now, we have a little symbol for that. We don't write the word arc, WX. We put a little one of these things over top of it. All right? So that little thing right there means what? It means arc. So arc is equal to, it's got to be a certain degree. Everybody with me? So if this is 60 degrees, watch. If I start here and I went to there, that's 60 degrees. What if I went all the way around like this? How much would that be? 360. So how do you think that we, how do you think we measure an arc?
From the central angle.
Okay, well, it's not from the central angle. The arc itself would go from here to here, but what would we use? We would use a degree, right? Just like we do with the degrees. So if this is 60 degrees right here, how many degrees do you think that arc is? It's also 60 degrees. All right? So here's our first theorem, basically. Our first theorem says that the central angle is equal to the arc that it cuts off. They say that a lot, cuts off. What does that mean? That means if you start here and this angle goes to here and this angle goes to here, it cuts off a part of that circle. Everybody see that? So the angle cuts off an arc. So the arc is equal to the central angle, all right? The intercepted arc, a lot of times they'll say that. The intercepted arc is equal to, I'll just put it down here, equals the what? The central angle. Very good. And that's really important. We're going to use that a lot. And then in the next, I believe it's the next lesson, we are going to do something a little different and not consider the central angle. We're going to look at another angle. But anyway, for right now, the arc is equal to the angle. Everybody got it? Very simple. Very simple. If this is 60, what's the arc? It's 60 degrees as well. Everybody with me on that? Okay, here's another thing. The arc is less than, one more thing. Just like line segments, I could have called this arc WX, or I could have called it, what else? XW. It doesn't make any difference, okay? What if I wanted to talk about, let's do another color. Let's go yellow. All right. My favorite color is blue. All right, so watch. If I start here, now my hand's a little shaky. Oh. See, I got nothing to brace my hand on. It's just loose. There we go. That's close enough. You get the idea, okay? I'm going around the whole entire thing. Now look, I started at W and I went all the way around to X, yes? So could I call that yellow one arc WX?
No.
No, because I don't know which one I'd be talking about, right? If I just said arc WX, how would I know if I'm talking about the red one or the yellow one? Agreed? So we have to have a way to differentiate between a smaller arc and a bigger arc, all right? Now this red one right here is less than 180 degrees, and we give that a name. I'm gonna write it over here. So when you have an arc that is less than 180 degrees, we call it a minor arc. Minor is lower, right? Would you agree? The minor leagues, right? If you play baseball, if you're in the minor leagues, you're in the lower division, all right? So it's less than, what, 180 degrees. Everybody got that? So this red one, okay, this arc WX would be a what kind of arc? A minor arc. What about the yellow one? That would be a, what do you think? This would be a major arc, right? Anything that's larger, okay, let's write it down, larger, or let's put greater than, less than greater than, that's a better word. So greater than 180 degrees. Now take a wild guess. What do you call that? A major arc, very good. So it's a major arc. So the yellow one would be a major arc, and the red one would be a what? Minor arc, all right? How do we name this yellow one? I can't just call it WX or XW because that would get confused with the red one right there. So yeah, you got to have a third point that's in the middle, okay? You got to have a point that's in between W and X, right? So when you do a major arc, okay, what we're going to do is use 3 letters instead of 2. Anytime you see 2 letters, it's always a what? Minor arc. Okay, whenever you see 3 letters, it's a what? Major arc. With one exception we're going to talk about in a second, all right? So how would I name that yellow arc right there? Arc what? Okay, you could go XYW or you could go WYX. It doesn't make any difference. Let's go XYW. Go the other direction. And you put a big old arc over top of that. So that's arc XYW. Now, wasn't really going to do this, but we'll do it now since I'm thinking about it. What would the measure of arc XYW be in this situation? 300, exactly right. How'd you get that? Yep, subtract the red one from 360 from the whole entire circle, and then you got what's left over, which is the yellow one, all right, which is 300 degrees. Everybody good with that so far? All right, so we got a minor arc, which is less than 180. We have a major arc, which is greater than 180. What do you think the next thing is going to be? We had less than 180. We got greater than 180. What are we missing? Yeah, equal to 180. So let's do that. So we got a line right here. That would be a diameter, wouldn't it? That WY? Yes? All right, so yeah, we'll just go this way. Oops, I don't want white. I want another color. What would really stand out? Blue. Oh, too late. All right, so what if I go all the way to there? Well, you know what? I should have done it the other way. Nah, it's okay. I'll stick another letter in there. I need another letter. Let's call it Z. All right, let's put a big old dot right there. Let's make it white, though, this time. All right, there we go. Put a big old dot right there, and we'll call that Z. All right. Now, what if I wanted to describe the blue one? It's not minor because it's not less than 180. It's not major because it's not greater than 180. It's actually equal to 180 degrees. So anything that's equal, or an arc that's equal to 180 degrees, has its own special name. And you've heard this word before. I don't know if you can think of it. Halfway around a circle, what would we call that? A semicircle. That's right, a semicircle, semicircle, however you want to say it. It really doesn't make any difference. All right, so semicircle. All right, so that's what we call a semicircle. If the arc is actually equal, it's dead on exactly 180 degrees, we call that a semicircle. Now, how are you going to write a semicircle? It's not a minor arc. is not a major arc, but could I call this blue one, could I call it just WY? No?
Yes.
Well, could I? Well, I could, but
It's the same book.
how would you know which one it is? How would you, if I said arc WY, how do you know it's not this arc right here?
But it wouldn't matter because it's the first one.
Yeah, but it's still different arc. They equal the same degree, right? They have the same measurement, angle measure, or degree measure, but they're not the same arc, right? This one goes way up here. This one goes way down here like this. You got to use a third letter, just like you did with a major arc, okay? So with a semicircle, you also have to use 3 letters, all right? Because if you didn't, I wouldn't know which one you're talking about. Agreed? And Tristan's right that they do equal the same thing. They're both 180 degrees, but they're still 2 different arcs, aren't they? Yeah. All right, so we have to name that. So how would I name that blue one right there? Arc what? WZY. All right, so arc WZY, put the little arc thing over top of it, and then that's equal to 180 degrees. And we call that a semicircle. You good with that? All right, let's move on.
Harder stuff now?
I don't know if it's harder, it's just different. All right, so let's draw another circle. And we're going to put some lines in here. Let's put a dot at the center. All right. Let's make a line that goes like this. By the way, if it goes all the way through and it goes through the center, what do I call that? The diameter. Very good. All right, here we go. This is W, and it's X, and it's V, and it's Z, and it's Y. It might, at first glance, this little thing, it's not even a theorem. It's called a postulate. Remember the difference between a postulate and a theorem? Postulate is accepted without fact or without proof, right? We just accept it, right? And so this is something that we can just kind of look at and you say, oh yeah, I see that. It's not that hard to see. But I think it's important because of what we're going to do a little bit later. So they have this thing called the arc addition postulate. So let's look at arc XZ. So if I said arc XZ, am I going to go down here like this or up here like this? If I just said arc XZ, I'm going to go down. Why am I going to go down? It's a minor arc, that's right, because 180 would go to here, wouldn't it? All right, and if that's Z, that's less than 180, yeah? So arc XY or XZ would be from here to here. So arc XZ. Now, if you take a look at it, let's look at the angles instead of just the arc. Well, we could do the arc too, but let's do the angles first because we're used to doing angles, all right? Not so used to arcs. So look at this angle right there. You see that? And look at this little angle right there. So, I don't know. Let's just make something up. If that was 120 and this was 30, then what is that whole big angle from here to here to here? XVZ. Be 150. What'd you do? You added them up, right? So we know how to add angles together, but we haven't done that with arcs. We just started learning about arcs. But the same thing would be true about that. So if that angle is 120, that's a central angle. This arc would be 120, agreed? And this little arc right here, ZY, would be what? 30 degrees, all right? And so our little postulate says this. If arc XZ is equal to this arc, which is what? That 120. How would I name the arc? This 120 arc, what would I name it? XY, yeah. XY plus what? YZ, good. And they call this the arc addition postulate. All it's doing is, and it's kind of like, yeah, of course that's happening. All right, it's one of those things. It's not like this big revelation. But it's just saying that you can add up arcs, right? You add up 2 smaller ones to make a bigger one. That's basically all it's doing. So it's saying, well, I'll do different colors again. So it's saying that arc X, oh, come on. I'm so squiggly. It looks like I'm nervous or something. I'm really not. So it says that blue one and the yellow one's supposed to be archy looking. Let's try that again. That's a little better. All right, so the blue one and the yellow one add up to be that whole big XZ arc. Everybody see it? All right, that's all it's saying. It's not that big of a deal. I probably spent more time on that than I needed to. So let's use that thing that we just learned, and let's do an example. Everybody likes examples because that's the kind of stuff you're going to see on the homework, kind of stuff you're going to see on a quiz. So let's do it. Oops. All right, here we go. Let's put a circle here. Let's put a center. Let's put a couple things. It pretty much, I don't even, this might be just a waste of time. I think you could probably do this without me. It kind of looks like the same situation that we just talked about. Is it? I think it is. I think the letters and everything. Z, V. All right, this time. Oh, by the way, I don't know if I showed you this. What's the symbol for a circle? Anybody know that? Okay, so we did talk about that. Good. So a circle with a little dot, and then which letter do we use? A lot of letters to choose from. Which one do we use? V. Why? Because it's the center. All right. So I'll call this circle what? V. All right, good. It says find the measure of each arc. All right, so we want to find them all. So let's list them. There's 4 of them. Well, 4 that they ask for. So Z, W, Y. We're trying to find that one. And I'll put some stuff in here that they tell you, okay? I mean, without any information, there's really not much you can do unless it's a diameter or something. And one of them actually is this one right here. It's YXW. And it's ZW. And it's ZX. All right, they got to tell you a couple things, and here's what they tell you. Let's put this in a different color. Come on. Come on. Why isn't that clicking there? Finally. All right, they tell you that this is 60 degrees, this one right here, and they tell you this arc is 45 degrees. With that information, you should be able to find all the other stuff here. All right? So let's do the first one. ZWY, arc, ZWY. There's Z, there's W, there's Y. So I got to go from here, where? All the way around to where?
Y.
To Y. So it's everything except what? The 45. So we already did the math earlier. What's the math?
360 minus 45.
That's it. So it's 360 minus 45, and that is 315 degrees. So that's the first one. It's not too hard, is it? Like I said, this is almost a waste of time because we kind of already done this in our little discussion earlier, but that's all right. YXW. So there's Y, there's X, there's W. Yeah, that's just a straight line that goes through the center, doesn't it? So that means that this whole thing is what? 180. So no math involved. That was easy. What about this? Arc ZW. Now, do I go all the way around like this? Or do I go up like this? I go up, right, because that would be it's a minor arc, so it's got to be this one. So that's the arc right there. How do I do that?
You take Z and do it across, then put it across to be 30, and 180 minus.
Nah, just because this goes across doesn't mean it bisects that angle. All right, Tim.
So we know that WYX.
WYX. The arc WYX?
180. And we add 45 to 180. They subtract this.
Subtract it, not add it. Right? Because here, watch.
65 on the first piece now.
Doesn't matter.
No, I'm not saying that. It's just saying
Okay, watch. Why do you got to be mean? Look, that's what we're trying to find. Okay, that's what we're trying to find. Everybody see it?
Yeah.
All right. So we already know this, right? So we're just trying to find this one right here. So what do? 180 what? minus 45. 180 minus 45. And what's that? 135? Yeah. So that angle right there is 130. I'm sorry. From here to here is 135. So the arc is the same thing. So that arc is 135 degrees. Yes?
I just did it the opposite way.
All right. And one more is ZX. It's a minor arc, ZX. So the shortest distance from Z to X would be from here to here. All right, let's draw that. Let's use this kind of yellow. All right, what is it, ZX? All right, so I want to find that right there. That's what I'm looking for.
Would it be 165?
I might make this a lot more complicated than it has to be.
Would it be
All right.
165?
Is it?
Well, I don't want to know an answer. I don't care about the answer. I want to know how to get to the
Is
answer.
it 180 minus 60 plus 45?
Let's do this. Let's do this. This is what? What's this arc right here? That's 60. Agreed? What's this angle right here?
120.
Yeah. Why?
Because we know that WI is the half of that.
Right. It's 180 degrees, right? So, right. It's a straight line. This is 60. So this is what? 120. So that means from X to Y is what?
120.
It's not my answer though, is it?
No, we have to
It's 120 what?
plus
Plus the 45, right? So from here to here is 120. Then from here to here, they told us it was 45. So we just add those together. So 120 plus 45 is 165. So really, this isn't much different than stuff that we've done all year long, is it? Except for what? Just with circles, right. We're doing the same thing. I don't know if you remember, but if you watch videos from way back, I kind of say that, right? I'm like, you know the stuff that we're, like, think back to the first few weeks, okay? I said, see the stuff we're doing right here? This is what we're going to be doing the rest of the year. Except instead of doing it with triangles, we're going to be doing it with these other things, right? Or instead of doing it with line segments, we're going to do it with angles. Then we're going to do it with rectangles and parallelograms and all this other kind of stuff. And then eventually circles. And that's what we're doing. Would you agree with that statement then? Yeah, I knew what I was talking about, right? You probably had no clue. And that's fine because you'd never done this before. But really, is geometry getting harder and harder and harder as we go on?
Yeah.
You think so?
Not really.
I think it kind of stays the same. It's just we're doing the same thing over and over again, but we're just doing it with different shapes and different things like that. Okay? I really don't think it's getting a whole lot harder. I think it's just getting different. You definitely say it's different, right? Absolutely. All right, enough of that. When's this over? 10 till?
Yeah.
All right. So we've only been talking about the angles, the angle measure. But guess what we're going to talk about now? We're not going to talk about the angle that arc makes. We're going to talk about, what do you think? What's another way to measure something? Not just with angles, the length of it. That's right. Okay, we're going to talk about the length of the arc. So, we're dealing with circles, obviously. So, you probably already know something, and I think we taught it earlier this year. What is the length or the distance around the whole entire circle? Let's say you started right here. Okay? And you started here and you walked around that whole entire circle. There's a formula to figure out how far you walked. You remember? No? Give me a word. It's not distance. It is the distance around a circle. That is true. But there's more of a specific word that's kind of only used for circles. Circumference. Circumference. Okay? So the circumference of a circle. All right? So the circumference of the circle means what? Does it mean an angle? No, it means a distance, right? The distance all around that whole entire circle. Do you remember the formula? We've done this before. 2 pi r. Very good. It's 2 pi r. We had a discussion way back about pi. Not going to do that, but what do we use for pi? What number do we use? 3.14. Okay.
5926.
Yeah, but don't use all that. Just use 3.14. Okay. It's nice that you could say a whole bunch of decimals after, but it's not practical. Did we show that video in here about pi?
No, yeah.
I might have not been.
65.
I don't know.
Oh,
I don't know. But anyway, there's a lot of interesting videos about pi and how it came to being and all that stuff, but we're not going to talk about it today. So what if I said the radius, because there's the r is radius. What's the radius is 9. That's the only thing I know. I just know the distance from the center to any point on the circle. So how do I find the circumference? Circumference is what? 2 times pi times what?
65.
Times 9, which is what? 18 pi. And right now, it's perfectly fine. Just keep it 18 pi, all right? Because you know what you could do. You could just take this, go 18 times 3.14, get a decimal number. I just like leaving it in terms of pi. Is that all right? Okay. So that's not new. We've done that before in here. But what if I did this? What if I just asked you how far it was, not all around the whole entire circle, but just from this point to this point around the circle? We'll call this E, we'll call this D, and C, all right? And what if I gave you an angle? We'll use that 60 again. It's a nice, easy number, all right? So 60 degrees. So here's the question. What is the length around the circle from D to E? Or what is the length of the arc? Okay? So if I was going to walk around this, not straight line from D to E, you understand that, right? We're not cutting through the circle. It's a pond. It's a perfectly circular pond. Can't walk through it. It's got alligators in there. We don't want to do that. So you have to walk around, okay? So how far is it from point D to point E? Now, we know what it is around the whole entire circle, right? So, and we've kind of done what we're going to do here in a second before. How far is it from here to here? Are we going the whole way around the circle? No, we're going a certain percentage, right, or a certain fraction of the circle. What is that fraction? What is that percentage? 160? 1/6? How'd you get 1/6?
Full circle.
What math did you do? Give me the math.
60 over 360.
60 over 360. That's what I wanted to hear, okay?
That was right.
Well, I was just waiting for you to say it. You didn't say it. So watch. 60 over 360, all right? Because this is 60 degrees out of the whole thing. Would you agree? What's the whole way around it? It's 18 pi, isn't it? 18 pi. So this right here is the distance just from E to D, or D to E, all right? Yeah, you could put it over 1, and then you could simplify it. It actually comes out, yeah, because it's 1/6, right? Because 60 over 360 is 1/6, right? So it's 1/6 of 18, which does what? Watch, that 6 goes into that. How many times? 6. So basically it's just what? 18 pi over what? 6. 18 over 6 is 3. So what is it? It's 3 pi. So the length of the arc, and we don't have like a symbol for it. We just put the word length. It's supposed to be an L. It's weird looking. But length of arc DE. All right? So the length of arc DE is equal to 3 pi. And then whatever the units are, I didn't put any units in here, but let's say I did. Let's say it's feet. So what would this be? 3 pi what? Feet. Is it feet squared? No, because it's just a length. It's just a distance around it. We're not finding the area. Okay? So that's how you do it. Very similar to stuff we've done before, right? Remember we found the area of the sector? And we did like, if I wanted to find the area of this, right, we would just go 60 over 360, what? Pi r squared. But now we're finding not the area of it, we're just finding the length from one point to another on the circle, right? So it's just part of the whole circumference, isn't it? It's 1/6. That's why I picked that easy number 60, right, to make it the math work out nice and easy. Possibly. All right. And they actually have a theorem for it. The theorem is the L for length is equal to whatever your angle is. What do we use for an unknown angle? Theta, right? Remember that? Theta over 360, what? 2 pi r. Or they actually do this. They put times c, which is the what? Circumference, okay? So that's kind of a nice little compact way. Do you really have to memorize that? No, because you already know, right? You know you're just going around a little part of the circle, so it's 60, or whatever the angle is, right, divided by 360. It's not always going to be pretty like that. It could be like a 57. That would be really ugly, wouldn't it?
Yeah.
All right? But you could always use a calculator, plug it in, get what you get. Make sense? All right, well, let's do a couple examples and we'll be done. Well, at least for this part. Let's see, is there much after that? Yeah, there's a little bit more after that. But that's okay. For today, we've gotten a good chunk of this done, all right? You'll be able to do most of it. There'll be some at the end you won't be able to do. So I actually got 3 circles here.
Oh, great.
But they're 3 problems. They're 3 different, separate problems. All right. All right, so... All right, don't lose me, guys. Stay with me. All right, here's what we're doing. It says find the value of each variable, and they say that this is 10 and this is L. So if they put the L there, where do you think the length they're asking for? It's from here to here. All right, they don't label it with letters or anything, but it's this one. I'll just make it a little bit thicker. See that? That's what we're trying to find. So what do? Oh, they tell you that. Okay, there we go. Now what do we do? Yep, 90 over 360, because we're not finding the circumference of the whole thing. We're just finding this little length of that arc right there. 90 over 360, what? Times the circumference. What's the circumference of it? 2, what? Pi r, which is 10. And you're right, it is 20. I just wanted to write it down so everybody sees. Okay? And then I'll do the math for you, and it comes out to 5 pi. All right? If
Teachers and students, just a reminder, we'll be selling Chick-fil-A breakfast sandwiches in the carpool lane tomorrow for $5 each. Thank you.
either one of these are fine. Okay? Everybody got that? Yeah, easy. Now let's do this one's a little trickier. That was pretty straightforward because they just found the length. Running out of time. I wish I had a few more minutes, but that's all right. We got tomorrow. I want to get at least these 2 done. Don't know if I can. All right, this time they put an angle right there. They tell you the radius like they did on the other one, but they also tell you the arc. They tell you this arc is 5 pi. Okay? So here we go. Let's do it. 5 pi is the length of this arc. Okay, so let's do it. What's the formula? The length equals, so what is the length?
5 pi
Equals what?
theta.
Right, this time it's theta because we don't know what it is. Over what? 360 times what? 2 pi r, which is 15, right? And it's going to be 30. So let's just do that. Is that all right? I'll take that 2 and that 15 and make it a 30. Again, it's over 1, so let's see what happens. Well, first of all, the pi's cancel each other out, don't they? Divide both sides by pi. Just hang on a sec. The zeros cancel. This goes once. This goes what? 12. So I multiply both sides by 12. And so what is theta? It's 60. It's an angle, so it's 60 what? Degrees. And that's how you do it. Okay? There's one more that they give you where you have to find the radius. We'll do that tomorrow. Just remember where we left off, okay? So try to get as much of the homework done as possible because that's less you have to do tomorrow, okay? And tomorrow is the weekend, right? Beginning of the weekend. So you want to make sure you get as much as you done as you can,